snazzy term, so we don't really like write it out, but we could call it non-mutually exclusive. You guys have heard it before, right? In like pop culture these days, if something's really exclusive, if there's like an exclusive event, or if a person is really exclusive, what do they do, or how do they act, or what does that mean if something's exclusive? Only certain people get in, right? If it's like an event or a venue or something like that, or a concert, if it's really exclusive, only certain people get in. If you're an exclusive person, you only let certain people in. Understandable, and yet it's still kind of dangerous. Non-mutually exclusive, oh no, it's okay. So non-mutually exclusive, guys, these are Venn diagrams, right? We've seen these before. Venn diagrams, there's an A and a B, and it's possible for both to be true at the same time. If I add up all the A and add up all the B, well, I just double counted the overlap. And so one way of remembering this formula is to say, yes, we add together. Ors are adding. However, we have to subtract or take away the double count. Subtract the overlap. But down here, what's true about A and B? Let me see. On Friday, what if I had said, how many of you guys are wearing khaki bottoms or jean bottoms? Everybody with khakis, stand up, sit down. Everybody with jeans, stand up, sit down. Why would I not have to worry about an overlap? It shouldn't be possible, if it is possible. It shouldn't be possible for someone, it shouldn't be possible, so. And I did not see anyone in here wearing khaki and jean on their bottoms as far as pants or shorts or anything else on Friday. So, not talking about jean jackets or jean shoes or anything else jean. I meant jeans. I don't know. It was a thing once upon a time. Just don't get them wet. Just like you don't want jeans to get wet. Anyway, but yeah, those are mutually exclusive. You're either wearing khakis or you're wearing jeans, and maybe there are a few with like cute striped shirts or plaid skirts is what I was trying to say. Okay? But mutually exclusive, it's like they can't happen at the same time. By one happening, it excludes the other. By the other happening, it excludes the ones. Just add them both together, no big deal. Okay, so I want you guys to powwow in your groups really quickly, collaborate and say, what would be the probability of drawing a red card if you're drawing one card from a standard of cards, no joker? What's the probability of drawing a red or an ace? Go. Jason, how are you falling asleep if you're supposed to be talking to your group? How is that possible? Does Jason know how many cards are in a deck? No, this is good though, right? Because cards can get tricky. Yeah, Adam, I'm going to write down what you're writing. Tell me what you're writing.
Okay, there are 52 cards in the deck.
Okay. So a standard deck. Because some of you guys for homework, if you don't know what a standard deck of cards is, well, or you didn't have a family growing up that played cards. So a standard deck of cards, 50 cards total, right? And then we could say optional, additional, 2 jokers. But that's rarely true. So there could be up to 54 if you're doing jokers or wilds or something like that. That looks like odd. Sorry, I meant additional. So there could be up to 54 cards, but normally there's 52. Okay, what do we know about those 52 cards? Okay, so half, 26 are black, and 26 are red. What else do we know? No. But everything that anyone should need to know about a deck of cards. Right? What else is there? As you guys are doing this, just in case someone's not visually tracking. This is what we're talking about, right? They're not all missing, right? Standard deck of cards, true? That's what we're talking about? Okay, that's what we're talking about. So we have, some are black, some are red, unless you have like a weird deck that they use different colors, which is really awkward. But out of the black cards, what are 2 characteristics that are black? Okay, we have 13 that are going to be clubs. We have 13 that are going to be spades. How about the red? What do we have? So we have, wait, which one's this? Spades. And we can tell by the little shape. And then which one is this? It's an 8 of clubs. Think St. Patrick's Day was yesterday, right? 4-leaf clover, except this one's 3. Now red cards, what do we have? There's the obvious one. There's the hearts, right? So we have 13 hearts. And what else do we have? 13, there we go, diamonds. Whoa, I just found how many aces very quickly? I think I just found like 3 of them. I don't know if I found all 4. But each of these suits is what we would call them, right? So these are our suits. Not as in the TV show. Good show, but a little bit awkward at times. What are those 13 cards?
Ace through king.
Ace through king? Depends how you do it. So either ace is low or ace is high. So if you counted the ace like a 1, then you're going to go 1, 2, 3, 4, 1 through 10. Let's go ahead and do this. Can't we say it's 2 through 10? Because those are the ones with actual numbers on the cards. Not thinking about how points are sometimes dealt. Then we can have the ace. Well, let's not go in that order. That's awkward, right? If we're going to go 10, we may as well go jack, queen, king, ace. And that's for per each suit. So now, what were you guys thinking about in your groups when it was the probability of having a red card or an ace? How many ways could we get a red card? How many ways could we get an ace? And then is there an overlap? Pause. How many ways could we get a red card? 26 out of. Probability, it's a fraction. You don't just say 26. You say, okay, 26 possible out of 52 plus. How many ways can you get an ace? Because there's 1 per suit, right? So there's 4 aces. So 4 out of 52. But why would it be wrong if we said 30 out of 52? 2 of those aces are going to be red cards also. So we just double counted. So we have to subtract the 2 red aces. Because if you were to lay out all 26 red cards, there would not be 4 aces left. There would only be 2 black aces, right? This is what I mean by subtract the probability of having a red and an ace, a red ace. So the final answer is 28 out of 52, which of course you could reduce by dividing both by 4, which would be 7 over 13, I think, yeah? Boop. Did we also get down the key details for a standard deck of cards, just in case you didn't know what it was? Hopefully. Yeah, what's up, Kathy? Because according to my formula, if there's an overlap, if there's a way for both characteristics to be true at the same time, there are 2 of those red cards that are also aces. So I counted 2 red aces here and 2 red aces there when there are only 2 of them, not 4 of them. So I had to take away one of the overlaps. So I asked myself, how many red aces are there? You see it? Okay. Last try. What else do we have? Complementary events. Wait, complementary? Are they very nice to each other? No. Nope. That's with an I, right? Complement. Adam, nice shoes today. Just because it's his birthday. No, that's not what this is talking about. Not complimenting something, but complementing. Complementing. Complementary. Huh. Maybe some of you guys have heard preached in your churches, if you go to church, if you hold to the Christian faith. If they ever have a sermon about marriage, and if your pastor is one that has a very good grasp on the Word of God and how God views marriage, does he say, husband, beat thine wives? No! Husband and wife are supposed to be complementary roles, complementing each other. Complementing? Well, I mean, it's good to do that every now and then in any close relationship, but complementing. What's complement mean? What's complement mean? Kind of. Bouncing, like in a marriage, it would be bouncing off each other, working on both of each other's, benefiting from each other's strengths, giving grace to each other's weaknesses, coming. Oh, that's interesting. Yeah. Because even the complement of an angle, wasn't that two angles coming together to make 90? Supplement, okay, we had to have another word for coming together to be 180, whatever. But anyway, just kidding, there's probably more to it than that. But either way, complementing, coming together. Huh. Then why does this say the chances of an event not occurring? That seems awfully divisive to me. What are the chances it's going to rain today? From what I've seen, pretty much zero. From what I've seen, pretty much zero. So what's the chances of it? What did I just say? Chances of it raining today, zero. So what are the chances of it not raining? Well, how would you say that? Because either it's raining or it's... Meaning, like either it's going to rain or it's not going to rain, true? What if I say the chances of it raining on Wednesday? I think last I saw was 25%. If the chances of it raining is 25%, what are the chances of it not raining? Oh my goodness, you put them together and they make 100%? Complement! Either an event happens or it doesn't. Now, there are some things like wordings, like at least, which make this a bit difficult. Because sometimes in a certain event, it's not just a binary type of decision where it's like A or B or that's it. It's either A or B. It rains or it doesn't rain. Done. Sometimes there's something like, there are 3 stoplights between here and, not Nordhoff, between here and Rinaldi? Anyway, just imagine there are 3 stoplights. Choop, 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 choop. What are the chances of you getting one of them red? What are the chances of you not getting one of them red? Do those add up to 100%? Do you either get 1 red or not get 1 red? Couldn't you get 2 red? Sometimes there are more than just 2 things that can happen. And if there are more than just 2 things that can happen, well, there are more things that would add up to 100%. So we have to be careful. But complementary events basically say the chances of an event not occurring or all the chances should add up to 100%. You guys agree? All the chances to any situation. I'm saying sometimes there are only 2 and sometimes there are way more. But all of them should add up to 100%. So if it's a binary decision, if it's either A or B and that's it, A occurs or B occurs and that's it, I could say, okay, the probability of not A occurring, quick notation, the probability of not occurring could be 100% minus the probability of A occurring, which is the same thing as 1 minus the probability of A occurring. I'm basically thinking of what else could happen. What else could happen? So if I'm thinking of the complement to A, which would be the same thing as the probability of not A, and there's a little notation for that sometimes. All I have to do is do 1 minus. But this only works simply if it's an A or B thing, like rain or not rain. But as soon as there are 3 stoplights, and I'm like, hey, you're going to hit 1 red or you're not going to hit 1 red. Well, wait a minute. Couldn't you hit 2 red? Aw, there are more things adding up to that 100%. We have to be a little more careful. Usually, when do we use this besides when they say find the complement of? It's mainly useful when the anti-options or the complements, and I'm going to put apostrophe S because there could be more than one complement, but the complements are easier to find than the actual probabilities. So when I asked you something like, what's the probability that you hit one of those lights red, you're like, I have no idea. How am I supposed to know if you get it red or not, and what's going to, like, what time you pass through and how many cars are there, and I don't know. But let's say I was to tell you something like, hey, the probability of hitting at least one of the stoplights red is 82%. The probability of hitting at least one of the stoplights red is 82%. And I ask you, what's the probability of not hitting any of them red? You're like, oh, it's easy. I know the 82%, so it's 1 minus that, because it's either you hit at least one or you hit none. There you go. It's a binary sort of relationship. But if I was to ask you, what's the probability of hitting at least one red? You're like, well, I could hit 1 red, 2 red, or 3 red, and then I could hit the first red and the next 2 not, or the second one red and the next 2 not, or the third one red and the next 2 not, or the first and second and not the third, or the second and third and not the first. Oh, that'd be a lot of adding. Maybe an easier way to find at least one red is if you knew hitting none of them red. So if adding up the actual probabilities, the actual possibilities are too hard, it might be easier to do 1 minus and just figure out, okay, when does it not happen? And I'll do 1 minus that. Ready, set, ponder. Ready, set, ponder. A manufacturer has determined that a machine averages 1 faulty unit for every 1,000 it produces. Sounds like good odds, unless you're the one getting the faulty one. And unless that faulty one has something to do with keeping you alive. Scary. The manufacturer has determined that a machine averages 1 faulty unit for every 1,000 it produces. What is the probability that an order 200 units will have 1 or more faulty units? You wouldn't think very high. How do we find it? Someone tell me 1 way or 2 ways or 3 ways. What's a way this could be true? 1 or more faulty. I just didn't hear what you said, Kyle. Huh? Oh, yeah. But like, you have 200 things. What's 1 way that at least 1 would be faulty? Well, you could get just 1 faulty. That's it, out of the whole shipment, right? Or 2 faulty, or 3 faulty, or 4 faulty, or 5 faulty, or 6 faulty, or, oh my goodness, how many ors are there going to be? Do we really want to add all those and figure out what the math is to all those? What would be way easier than adding up all the ways it can be true? Thinking about when it's false. If I can figure out when it's false, 1 minus the complement. When is this false? How is it false if you have more faulty units? No faulty units. Oh, just one thing? Just one case? Just one thing to figure out? Yeah. Sweet. I want to figure out that one then. So we're going to do 1 minus when it's not true. And when it's not true, hold on, I have to take that off to the side. So what's the probability of having no faulty units? Pause. What's the probability of getting 1 faulty unit? You open 200 units, what needs to be true every single time? Not faulty, not faulty, not faulty. Hey, what's the probability of not faulty then? Those are good odds, yeah? Until you have to have it ring true 200 times in a row. Because doesn't the first one need to ring true? And the second one needs to have the same result, and the third one, and the fourth one, and the fifth one, and the sixth one? What's the probability of no faulty? Great odds, but raised to what power? It needs to be true 200 times. It needs to be true the first time, and the second time, and the third time, and the fourth time, and the fifth time. If you were playing the lottery, and your probability of using a number 99 or 1,000, yeah, pay that money, buy that ticket, go team. But if you had to have 200 numbers in a row that you got right, not just one, but 200 in a row, how are those odds? Anybody throwing that in your calculator yet? What's 0.999 raised to the 200th power? Don't do 1 minus yet. Just what's 0.99 raised to the 200th power? What if it needed to be true 200 times?
How many guesses?
Give me a few. Like 5. Right? 0.8. So what's the probability of you getting 200 non-faulty units? 81.865%. Okay, still pretty good. But is it as good as 99.9%? No. So what's the probability that you'll have one or more? Oh, you only had like a 0.1% back here. Oh, all of a sudden, a lot different. 1 minus or 100 is going to end up with 1918.2135. What if you had like 1,000, a shipment of 1,000? Then what? What's 0.999 raised to the 1,000th power? And that's what's 1 minus that? 63% is 0.999 raised to that, or 1 minus? 63%. So what do you think people that buy huge numbers of things usually account for? Yeah, something going wrong, right? Something being faulty, something being... So even in, I don't know, didn't I use with you guys the whole wedding flower thing? Like you look at it and you're like buying all these and you're like, oh, it's going to be good, this shipment of, and it's going to be perfect and it's going to be great. You always have to account for something not going right. You're good, you're good. That's it, and we're done. I'm going to dual page it. You guys, get down your homework spirals, whatever you need. If you have not yet started section 9.7, shame on you. Get it down. If you have, but you are thinking towards the review, which is due, well, we're reviewing tomorrow. You might want to get started on the review, because is section 9.7 homework horribly long and tedious and awful and disgusting? And it might be a little tricky from one problem to the next here and there, the word problems especially. All right, Jason, grab a seat. Write down the assignment if you need it. However, as you guys are writing those assignments down, guess what? I have my section 9.7, or I will have it, open and available for questions, because I know a few of you guys might have done the entire thing or might have done part of it until you got stuck, and maybe you have a question you're currently stuck on, and maybe today didn't help. Maybe it did, but maybe it didn't. And maybe the rest of your class would definitely benefit from hearing, ooh, this is a tricky one. Let's think through it together right now. Sound good? Why am I doing this? Because my goal for you tonight is not just to do this homework, but to start. Well, I was just thinking, hopefully not all homework. Hopefully the rest of it's been done for a while. But start the review. If you guys need a book, we still have 10 minutes. I don't mind. But where did we get stuck in section 9.7? Or where did it get hard? Oh, yeah. I can pull it back up. Does anybody have anything in 9.7? If not, it's okay. I'll just put the homework up on the board and you guys can... There you go, Jaden. Is it one that I can answer? Is it a hard one? It was the one you were asking me with. What number is it?
It was the at least problem with the...
Was it 52, 57, 60? 52, 57. Ooh, 60 is a good one. Do you guys want to peek at 60? It's an even and it's a long one. If you guys are like, meh, I can only get so much done anyway, you might want to do number 60 with us right now. If you guys want, in the back of your homework spiral, we're going to peek at number 60. It's a good one.
Oh yeah, this one's not fun.
Yeah? That's a good one. If you guys are starting at the beginning of 9-7, it doesn't start off that bad. There are some tricky things here and there, but number 60 might be a good one to talk about. A fire company keeps 2 rescue vehicles. We'll say they're in the mountains somewhere. That doesn't really help. That's more dangerous. Anyway, because of the demand on the vehicles, and the chance of mechanical failure, the probability that a specific vehicle is available when needed is 90%. That's good, right? Good odds, 90%. Unless you're the one whose arm is chopped off and is like, and no one can make it to you. Anyway, and you're the 10%. The availability of one vehicle is independent of the availability of the other. What does that mean? If the first car breaks down, does that mean the second car is going to break down later? Not necessarily. It's not like the 2-engine plane where one breaking down well, I guess the use of the second vehicle is, it gets used more. Anyway, they say it's independent, so fine. It's independent, one doesn't affect the other. Find the probability that both vehicles are available at any given time. So what needs to be true? Does vehicle 1 need to be available? Why am I drawing blanks? What section am I going back to? Or what principle? Where was that, where we were multiplying? Counting principle, yeah. Yeah, counting principle. The first vehicle needs to be available and the second vehicle needs to be available. What's the probability the first vehicle is available? 9/10 or 90%, right? What's the availability or the percentage or the probability that the second one's available? Oh, well, that's not too bad. Can't I then go ahead and just say it's 81%? What's letter B asking? Okay, so if neither vehicle is available, guys, why am I going to say think the complement? Careful. Not the complement to this, but the complement to this. What's the complement to the vehicle being available? If 90% chance it is available, what's the chance, the percentage chance it's not? 0.1. What's the chance that this guy's not available? 0.1. So what's 10% times 10% or 0.1 times 0.1? Whoa, I don't get it. Either both are available or both aren't. This should add up to 100 and it doesn't. Man, probability stinks. It's not true. What else can be true besides both of them being available or both not being available? One is and the other isn't. Or the other one is and the other one's not. So what's letter C asking? At least one vehicle is available. How could at least one vehicle be available? Adam's going straight for the complement. If we were to think about how this could be true, though, couldn't it be that the first one is available and the second one's not? Or the first one's not available and the second one is? Or both are available. Does that make sense? Either that one is and that one's not, or that one's not and that one is, or both of them are. Any of those cases, at least one vehicle is available at any given time. Who's the one guy that we're missing? So I could do 1 minus the probability of not the first and not the second, which would be 1 minus 0.01, which would be 0.99, or 99%. But guess what would happen if you had added this one plus 90% times 10% plus 10% 80%? There you go. So whenever you see the wording at least, there are 2 ways to do it. One way is to add up all the different possible ways it will work. The other way is to say, hey, when's it not true, and do 1 minus. But if you guys notice, there was more than just 2 options to this scenario. There were actually 4 different things that could actually occur. And all 4 of those needed to add together to make 100%. All 4 needed to add together to make 100%. Kiddos, with that, let me go ahead and just throw this back on the beginning of section 9.7. Because I didn't have any extra questions. For those of you guys that have not yet started homework, you probably won't get too much past the vocab. But some of you also have your books open. I'm totally cool just letting you guys work for 5 minutes. That sounds good to you? All right. If you guys are stuck on anything, let me know. Remember, if you start your review, what do you not have to write? Directions. Just show me work. And then tomorrow, we're going to go over questions to 9.7. And if you have them, which would be a good thing if you did, questions to the review. Sound good? A few hints about the test. P.S. on the test. You are allowed to use your calculator on the whole thing, but remember, do you remember what I said? There are going to be blanks in the multiple choice that say, but write the formula for. So you'll get all those sad little faces all over the room. So you'll be able to get points for the multiple choice, but also you'll see like, oh, she's expecting she'll give me points or take away points if I can't. So there's kind of some built-in hidden questions, not hidden, like they're there. Just make sure you read the whole question and fill in any blanks. So you're going to have to know your formulas, your factorials, things like that as well. But yes, you can use your calculator the whole time. All right. Period 1 attendance. Period 2 attendance. Adam, what are you doing for your birthday, bud? Nothing. You're just tired. Did you do anything this past weekend?